Cool. So so what we'll be going through today, yeah, as I said before, so we've looked at all the major spatial constraints with our project 2, and now we're looking at some of the other still important compliance aspects, but ones that don't flow onto other building elements significantly. So we'll be having a look at AS 1428.1 again, which is access for disability. So I think we've touched on door clearances previously, but we'll have another quick look at the door clearances. Also, things like how we deal with curbs, how we deal with what sort of tactile ground service indicators we need, etc. And also, we'll spend a fair bit of time on bathrooms. So bathrooms for disabled have to be designed differently than your standard bathroom, and that has impacts on the waterproofing requirements. Primarily because we have open showers, we can't have hobs and things like that, set downs, etc. for wheelchairs. Then we'll look very quickly at just some aspects of the design of lifts and escalators, once again for disabled access. That shouldn't take long at all. Following on from that, have a look at fire separation requirements for the building. So we have some intertenancy walls, and we're going to have to deal with those somehow, both from a fire resistance perspective and also from a sound insulation perspective. So it's not going to have major spatial impacts on the buildings, but we're going to have to ensure that they're the correct notes to bring those walls up to compliance. We're also going to have a look at fall protection. So how do we treat balustrades and handrails, and also openable windows? So it's not only that we have to think about stopping people falling off of balustrades, but also children, etc., out of operable windows. Then one aspect that may, well, in some instances it can have influence on the building fabric, but in our instance it's very unlikely, are the requirements for light and ventilation in buildings as well. So we'll have a look at those requirements for light and ventilation. So start off by bringing up Australian AS 1428, and so you should all be relatively familiar with this Australian standard by now. The aspects that we'll be concerned with today, that we'll be having a quick look at. Once again, paths of travel and circulation spaces. So page 14. Heading down to page 23, having a look at tactile ground service indicators. So that's a way of, it's primarily for vision impaired, but it helps communicate information about what's going on. Has everybody ever noticed on handrails, as you're getting toward the end of a handrail, there's a tiny little bump? That's to let people who are vision impaired, who are using that handrail, oh, there's a little bump. Things are changing here. This handrail is ending. It's just those little cues like that provide that information to people. Also, once again, having a very quick look at stairways and doors and circulation at doorways. Then the important one, having a look at the sanitary facilities, and then sanitary compartment for people with ambulant disabilities. So down on page 90. I'm going to have to add 2 to everything I put in. So an important aspect that, one aspect that's going to be important to us in our construction, but particularly for where we're in the car park area and leading in to the building, are construction tolerances for abutment of surfaces. So we don't want to have, well, we do want to have our parking spaces separated from our foot traffic areas. That makes perfect sense in terms of we can create those different heights to help delineate spaces for usage, so we don't have people parking in front of stairs and parking in front of lifts and things like that. But in doing so, we have to treat those transitions correctly. So the thing I just wanted to bring to your attention with this is that there is very little tolerance for height differences when you're dealing with access for people with disabilities. And this may have some impact upon paving choices, etc., for external paving. Also, fixed or recessed floor coverings, so soft floor coverings, carpets and other soft materials. Where carpets or any soft material are used on the ground or floor surface, the pile height or pile thickness shall not exceed 6 mm and carpet backing thickness should not exceed 4 mm. These are not things that that I expect you to be specifying on our project. That's more for going in the specification. So we're choosing a particular carpet, like this carpet, for example, would comply with that. But what I am expecting that you do is to have notes to say floor finishes to comply with AS 1428, etc., etc. And once again, leading edges, carpet trims, any soft flexible material should have a vertical face of no higher than 3 mm or rounded bevel edge no higher than 5 mm at that height of 1 in 8 up to a total maximum height of 10 mm. So once again, talking fairly low tolerances for changes in floor levels and changes in finishes. That has to be understood by the builders carrying out the work. Got page 23. So tactile ground surface indicators. So to warn people of hazards should comply with obviously AS 1428.4.1. So we're going to have a look at 0.4.1. And it's not going to be possible, obviously, for us to be putting a ramp into this building at, to have a ramp slope of maximum 1 in 14. We're going to have a very long winding ramp, probably taking a run up from the road nearby to get wheelchairs at that. But it is something that is, I guess, we won't be going through it today, but it's something that is very important or very handy for you to understand. A decent proportion of the work that I was carrying out at Imparter Engineers was that whenever we're updating facilities, we have to make them disabled access compliant, and there was a lot of ramps going in, and that was quite often quite a challenge with buildings as well to work out how we can incorporate those ramps in. So for your professional development, it's a handy thing. But walkways should comply with the following. A floor or ground surface abutting the sides of a walkway should provide a firm and level surface of different material to that of the walkway at the same level of the walkway. Follow the grade of the walkway and extend horizontally for a minimum of 600 mm unless one of the following is provided: a curb rail. That's our ramps. Railings. What I was hoping to come across is the slope relationships for curbs. So might have to come back to that one. Yeah, this section. So we have to provide, unless they are fire isolated stairways, we have to provide a stair which is disabled compliant, which requires that we have an additional stair width to any of our landings and an extension of the handrail by 300 millimeters, turning the handrail at the end through 380 degrees, and tactile ground surface indicators before and after the stairway to show that the stairway is about to start, about from approach of either direction. So with all of our doorways, it's important the internal door width is 850 millimeters. So there's a clear 850 millimeters. Based on our standard size doors, all of our, as probably many of you would have noticed, your standard size doors come in dimensions of 620, 720, 820, and 920. So that, because we have to have that internal opening of 850 millimeters, it rules out the 820 doors, and so we've got to go up to 920 doors. But the important one is on this page 58, and this is where it requires a little bit of lateral thinking in regards to how we're looking at the doors. With that project, we have the balcony at the front that's that movement space, or the approach for each of our units. Now, each of our units has to enable disabled access. To that, the doors have to comply with that. If we look at that balcony space simply as approaching the doors from a parallel fashion, so either we're approaching from this direction or from this direction, or this relates to any doors in that building, for that matter, any swing doors in that building, then we have to have these width requirements adjacent to the latch side of the door. And as many of you would have noticed on that plan, there's a fair bit of articulation of that front wall that's happening. Quite often on the latch side of the doors, there's not that required space. One very easy way or one possible way of producing that required space is actually hinging the door from the other side in relation to some doors. So if we look at it as a side approach, and we don't have that space on the latch side like that, but we have adequate space on our latch side for the hinge side in this situation. What we can do, we just flip the swing of that door around, so it's a fairly inexpensive procedure to carry out. Another way we can look at it is if the length of our corridor is wide enough, so we've got that length of 1450 or greater, we can then actually classify it as a front approach door. So rather than having to look at it simply as a door with a side approach, which would only, which we'd have to do if our corridor width is only that 1240 or 1210 or lower. If we have enough width in that corridor of 1450, and this also relates to the circulation spaces and the stairwells, etc. If we've got that space, we can then look at it as a front approach door, which reduces our area that's required on the latch side. Also, if any of you are putting in cavity sliding doors, we have circulation spaces around cavity slider doors as well. That's possibly if you want to be putting those in for your bathrooms, etc., to be saving a bit of space. I don't expect any cavity slider doors for front doors. Beyond that, we've got some constraints that relate to hardware. So once again, I'm not expecting you to specify any particular hardware, but to provide notes to say that hardware must comply with AS 1421, AS 1428.1 as well for all our disabled access doors. Okay, but the important thing for us in this project are bathroom facilities that are disabled compliant. Now you're fairly lucky in this term, or in this manner, in that you have those bathrooms which are already set out on Revit to enable those circulation spaces, and the simple approach is to stick with those bathrooms and those circulation spaces as set out, because you know that they're going to be compliant. However, you will have to still add some notes to those. So I'm not expecting notes in regard to dimensions of these, unless you're going to be changing some of those. But what you will have to have a look at, particularly, is shower areas. Although what I actually with compliance, in looking at your circulation spaces in disabled bathroom, have you gone through those circulation spaces quite well with compliance? Yeah. So if so let's say if you were to have to do renovations to an RSL hall or something like that, you would be able to work your way through this to design a bathroom to meet those. Okay, so we won't need to look into any of those. But have you covered showers in disabled bathrooms?
Quickly go through that, please.
Yes.
Because it was self-learning at that time.
Yeah.
Because our teacher was unwell, so we couldn't have. So yeah, it would be good if.
In terms of the showers?
Yeah,
Oh.
in this, yeah.
Yeah.
But even the circulation area.
Oh,
Yes, yeah.
Okay. Well, I haven't touched on this for a little while, so it's going to be a bit of a reminder for me.
Yeah.
No, we'll have a quick look. So, yeah. So basically, this is going to be. I'll shrink that down a little bit so we can fit it on the page yet. This is going to be your main go-to diagram that relates to the required circulation spaces. So you've got it set out what your location of your toilet has to be in relation to any grab rails, any walls, offsets from those walls, etc. So they're your minimum requirements. Good morning. But then, so those dimensions have to be adhered to with our location of our toilet and our location to grab rails, etc. But where on here you've got minimum, we have to meet those, at least those minimum requirements for enabling that circulation space. So that means you're allowed to exceed that as well. If you have a larger room, you can certainly exceed that. But yeah, so that's all the dimensions that relate to clearance away from other objects. You can increase them, but some of these dimensions are set hard and fast dimensions because it relates to being able to reach grab rails, etc., and having adequate or correct distances spacing from walls. So within that exclusion zone, you can't have anything else. However, you also have exclusion zones around your hand basins and things like that. They can be shared with other exclusion zones. So as long as those exclusion zones are free, then you're allowed to share those things. And that's the way you have it set out on your Revit model, is that you have those exclusion zones shown that are attached to each of those bathroom elements. And so say if we had an exclusion zone attached to this hand basin, that can extend out to here as well, as long as it doesn't include any other feature within that. Once again, for your wash basins, apologies, I don't know how to rotate that screen to make that a better view. There are some minimum requirements, but then there are also range requirements. So from 800 to 830. So it has to. So the height of the basin has to be within that range, that 30mm range. And once again, circulation spaces. So that circulation space can be shared with other elements in the bathroom. So what's going to be important for us, and a feature that takes up a lot of the space within the bathroom that has a very large circulation space, is the shower. So in looking at our showers, there are several important points. Do I have? I'm just going to see if I can grab regards to the floor. No, I'm not. see any diagrams that relate specifically to the floor. But the short of it is that with a disabled bathroom, you're not allowed to have any defined set downs or hobs to enclose that shower area. That shower area has to be part of the open floor. So just like when we looked at our changes in ground levels, etc., for finished like carpets, etc., or for paving, same requirements are applying to our bathroom and our shower area. We can't have anything set any steps greater than 3 millimeters in that. So that means we have to have an unenclosed shower. Also, we have a feature whereby our shower rose has to be on a 1200 millimeter hose as well. So that will extend the possibility of where that shower can be within that bathroom. So we have to extend our waterproofing for that significantly. We also have to include a folding seat within the shower. Now, I think those folding seats are already shown in your Revit model. They're actually shown as a block. So if you're going to do a section through there, you have to note that as a folding seat rather than a built-in block, because it's intended to be able to be folded away. So so once again, you're going to have those notes that your shower areas to comply with AS 1428.1. So given that, so here we have our diagram showing in elevation the shower rose on a 1200 millimeter hose and the location of that shower rose. Also, I'll draw this to your attention, and we'll go into this in a minute. Within our wet areas, South Australia is a little bit unique. Well, within the NCC, each state has its state and territory variations, and South Australia has variations that relate to these floor slopes as well. So that's revision for building rules consent people. Here, just to put it in a nutshell, within the general floor area for South Australia, it's maximum, it's 1 in 80 falls. So for the rest of the country, it's between 1 in 80 and 1 in 100. For South Australia, it has to be 1 in 80 falls to your main bathroom area, and in the shower for the nation, it's 1 in 60 to 1 in 80. In South Australia, it's falls of 1 in 60 to shower area. So because we can't have enclosed showers for our disabled bathrooms, what we have to now look at is how we end up treating the waterproofing requirements of those unenclosed showers. So for that, go to our section here, and we've got general shower area requirements. So I'll quickly look at that, and then we'll go back to some other elements within AS 3740, and just quickly. AS 3740 relates to waterproofing of domestic wet areas. So for the three of you that are doing the planning approval only, have you had any reference to AS 3740 before, or connection with that?
I don't think so.
Yeah. So it's a how to say it? It's an Australian standard that you will have to get to know fairly well. However, typically what you do in practice is you produce sheets of wet area details and then attach those sheets to all of your building projects. Within this subject, what you're required to do is, for project 2, provide wet area details. You produce your wet area details based on AS 3740. Now you're only required to produce those wet area details for a limited amount, a limited view of your building. So you're not going to be producing a full sort of 3 pages of wet area details. But for your standard practice, if you're, well, typically if you're going to be working in an office, they'll have those wet area details created already. But if you're going to be doing that for yourself, I encourage you to pour through AS 3740 to produce your pages of generic wet area details for attachment to any of your drawing projects.
Do you only need to do it for one of the bathrooms?
For project 2, yes. Yeah. And so do the. I suggest you do the wet area details for your disabled bathroom. So for your disabled unit. So typically with your showers, you're going to have scenarios whereby you have a separation of floor between your shower and your main bathroom. So this is a cross section through, and this is one of the details you would typically include in your larger sheets of details for wet areas. When you have that set down for the shower, you'll have a waterproofing membrane that carries underneath your screed. So screed, tile bed, same thing. You have that waterproofing membrane that carries underneath that and carries to a water stop which goes beneath your tiles there. Or there's another detail whereby that water stop may continue up. I'll find it later. Where that water stop may continue up under your shower screen as well. But what we have to do is we have to ensure that any of the water in the base of that shower, it can penetrate into our tile bed and our tile screed, and that's drained out by the use of a puddle flange, and show those a little later on. But we have to ensure that none of that water makes it through into our concrete slab, because concrete slabs are water resistant, but they're not waterproof. And for continued exposure, we can rust out the steel in our concrete slab if we allow water penetration through there. So that's where we have a set down and an enclosed shower. Obviously, we can't do that when we're talking about disabled bathrooms. So where we have, and there's our detail for a water stop underneath a shower screen, extending 5mm above the floor level. Actually, I'll duck up to this detail here, but this is the one that won't entirely apply with us, because once again we've got to set down a frame of shower screen. But where we do have water that's going out past our shower area, we have to include a water stop in the general floor area. So these water stops, they're made by either aluminium angles or more commonly plastic angles. So just small plastic angles that are fixed to the floor, and then the screed goes, well, then your waterproofing membrane goes there, and then your screed goes on top of that, and the water stop has to finish at exactly the same height as your tiles. You don't want that water stop going past your tiles, because it's a trip hazard, but it's unattractive, and it will result in the breakdown of your membrane. But we also don't want that water stop going down beneath our tiles as well, because that will allow the bleeding and the sharing of water between those areas. So you have to include a water stop, and then you paint on your waterproofing membrane to that.
Michael?
Yep.
If for the disabled bathroom, you don't have the screen door, so we don't have to put the water stop there because it's the disabled.
Yes.
Access to the bathroom, you need to just yes. I mean, if we use the water stop, they will be stop the disabled people from the wheelchair into the shower area.
Yeah. So the water stop for a disabled bathroom, because we don't have this, we don't have any shower screens, etc. Imagine this, if we're looking at this detail without any of that shower set down and that shower screen. So this, yeah.
There are
Okay.
obvious,
Yeah.
things in-
Yeah. Well. Okay.
Further down.
Yeah. Scoot down and find obvious detail. Take a little. So that's for the hob. Details of hobless.
No, it was
It's
up, yeah.
further up.
There, yeah. Oh, yes, within this area. only.
Yeah. So,
until still.
yeah. Well, before I go straight into that detail, I'll just cover this section here. So we're dealing with an unenclosed shower because we can't enclose it. We can't have any screens there to be getting in the way of a wheelchair. So there are several types of unenclosed showers. Type 1 is when you have an unenclosed shower that has a device that will restrict splashing during use. So that's typically what you're going to see a little bit more in your, I don't know, inverted commas, high-end residential, where we don't actually have so much a separated shower area, but we have screens to stop that splashing. So we have large open bathrooms and unenclosed showers. So that's our type 1. But unfortunately, we won't be able to do that with our disabled bathroom either, because once again, that screen to stop splashing will also be getting in the way of the wheelchair, and that'll be an element within that exclusion zone. So we have to go with what's type 2. So type 2, unenclosed shower, does not have a device that will restrict splashing. So example of type 2 unenclosed shower is shower for people with disabilities. The water stop of type 2 shower should be a distance of a minimum of 1500 millimetres from the wall connection of the shower rose. Type 1 and type 2 unenclosed showers, the water stop should have the vertical leg finish flush with the finished floor surface of the floor. And where the water stop intersects with or joins a wall, the junction should be waterproof. So quickly, I dare say it's going to be above that water stop details for unenclosed shower. Oh no, it's definitely beneath that. Yeah. So that's for showers with hobs, so we can't use a hob. So a hob is a built-up area of the shower that stops that water flow. No, yeah, I can't find that detail. But where we have, and there are two different approaches. This approach where we have a water stop going from our initial concrete slab all the way up and waterproofing underneath our screed. That's where we have a wet screed, and we use what's called a puddle flange to enable the bleeding of the water out of that screed. And then this is where we have a dry screed, where we have our waterproofing membrane underneath our tiles and a short water stop. This detail is by far the most common detail for use in South Australia. Reason for that is that if we go putting our waterproofing membrane on top of our screed, then we end up fixing our tiles with our adhesive on the top of that waterproofing membrane. We have issues with compatibility of products, but then we also have damage of that waterproofing membrane whenever we go to renovate a bathroom. So where we have that unenclosed shower, so this is our shower area, this is included as our shower area here to that water stop, and that's to the bathroom area. So on this side, we've got a 1 in 60 fall. On that side, we've got a 1 in 80 fall. So what I'll also have to show in this, so that shows our extent of our of where we have to do waterproofing to the shower floor. Now, does everybody know what a waterproofing membrane is?
A sheet, plastic sheet, that sits in between the grout and tiles, basically.
Yep. Yeah. Richard, you've seen waterproofing membranes before? Yep. No. So I'll quickly. I expect probably if any of you have been visiting any buildings under construction, you would have seen this. Now let's do. Actually. So this type of thing where they're painted on to floor areas. So typically in colours like the greys, green, pinks, and purples. So that's a bathroom with a lot of waterproofing. They've gone a bit over the top with that waterproofing. And here, once again, well that certainly exceeds requirements. So what you do is you paint on a primer, and then enable that to dry, and then you paint on the waterproofing membrane. That goes off, and that ends up forming like that plasticky coat underneath all your tiles, etc. What's that? Getting it, yeah. So that waterproofing membrane has to go onto water-resistant substrates. So it's not only about things in your bathroom having to be waterproof in certain sections, but also water-resistant in other sections. And this is also an important part of your waterproofing details. So we've got those waterproofing details that show our water stop, but toward the end of AS 3740, you've got various different scenarios that set out what elements within the bathroom are required to be waterproof and what elements in the bathroom can remain as water resistant. You have to put your waterproof, well there's certain constraints about what your waterproofing membrane can go on top of. Typically you're going to use a water resistant substrate for that waterproofing initially. So if we have a look at these details, the extent of a water stop, as you probably remember from the disabled bathroom as well, is that 1500 millimeters from the shower rose has to be waterproof. So waterproof entire floor to 1500 millimeters from the shower rose. So that's for any unenclosed shower that you need to do that. And then going down to shower areas in general, so waterproofing to 1500 millimeters from that shower rose to the extent of the floor, and then waterproof junction to the wall and 25 millimeters above finished floor level. So wherever you've got your wall junctions, you have to waterproof to 25 millimeters above finished floor level. The implications of that are that when you paint on this waterproofing membrane, you don't want to paint your walls over top of it because it is that thick plasticky type membrane. You're going to have this lumpy surface there. So that's why you see for in your bathrooms, like for minimum tiling, still 150 millimeters of tiles going all the way around the edge of the bathroom. Is because you have to waterproof those junctions. Also, within your shower, you have to waterproof the wall junctions. So to 40 millimeters either side, to the height of 1800 millimeters from the floor. Then the rest of that shower, from 1500 millimeters from the shower rose to 1800 from the floor, has to be of a water resistant material. Your typical water resistant materials are going to be like moisture resistant plasterboard and other sheeting, like wet area sheeting products. And typically what's going to happen is, yes, you have your minimum requirements as set out in AS 3740, but you're going to use water resistant sheeting for the entire bathroom. One particular note that, well, one thing also that relates to, well, doesn't relate to project 2, but to many other dwellings you might have to work with, is that you can actually do a timber floor within a wet area as well. But if you do a timber floor within a wet area, you have to carry the waterproofing membrane for the entirety of the floor. So your waterproofing details are going to incorporate information such as this to show which areas of your bathroom are waterproof and water resistant. So one really good way of showing that within your drawings of project 2 is with your cross section. Then you can show your dark shaded areas for waterproof, lighter shaded areas for water resistant. And that's, if you go up to, was it page 9, you can go in here to see the definition of what materials are waterproof and what are water resistant. So we've got materials to page 9. So waterproof materials, stainless steel, copper, flexible waterproof sheet flooring material may also be an option, or what's typically used are membranes meeting the requirements of AS 4858. And then water resistant substrates. So for walls, concrete in accordance with AS 3600, cement render, fibre cement sheeting, and water resistant plasterboard and masonry in accordance with AS 3700. And then floors, concrete, compressed fibre cement sheeting manufactured, etc., floor grade particle board sheeting, and structural plywood. But for these last two, for particle board and plywood, you have to waterproof the entire floor. Beyond that, important details for your waterproofing. I don't expect anybody's going to be drawing in a recessed soap holder in their showers, but I'll just quickly touch on that because this is something that's it's almost expected in bathrooms currently. A recessed soap holders, I think they are a bit of a time bomb, but for your recessed soap holders, have to have a fall in the base of the soap holder to drain to the shower recess, and junctions flashed and complete holder waterproofed. So when it says junctions flashed, that means with the tape, with the waterproof taping, and then you do your waterproof membrane over the entirety of that soap holder as well, and have a slope to the rest of the shower area. But what I was going to take you to, the last aspect for your waterproofing details are bond breakers. So for your waterproofing membranes, you've got various different classifications of waterproofing membrane. Class 1 and Class 2 membranes are very rigid membranes. So that includes things like fiberglass sheeting and other more durable membrane products, which you typically don't use in a residential application. So with those more rigid type of membranes, you have to include a bond breaker which is designed to allow more protection to that membrane if there's some movement in the structure. So you may have to employ these type of things if you're doing waterproof membranes in like aquatic centres, things like that, where they get a great deal of use and there's some form of abrasion, or in things like possibly abattoirs or other areas where you're having waterproofing requirements, but a lot of activity going on, and you need far more durable waterproofing membranes. But for our by and large, what you're going to be dealing with is a Class 3 membrane. So whenever you have a timber framed structure, you have to use a Class 3 membrane because it's the only one that has that flexibility to work with a timber framing. So the Class 3 membrane is more flexible. Given that Class 3 membrane is more flexible, when you get down to these corners here, well, you still need to have a bond breaker. So with any membrane, you need to have a bond breaker to ensure that membrane doesn't get painted right into the corner there. Because if that membrane gets painted right into the corner and there's some movement, it'll crack. Whereas if you do a bead of neutral cure silicone and finish that as a cove, then that membrane will not crack whenever there's a little bit of movement in the building. So typically that's going to be the detail which is going to be used. But with your wet area, with your large sheets of wet area details you might put together for professional practice, you draw up all of these 3 details and include those on there. So if ever there is a specification of a Class 2 or Class 3 membrane, those details are there. For our project 2, we'll just be looking at this Class 3 membrane. Also, you have to provide drainage to your floor area as well. Now, what typically happens with a lot of modern construction is that where bathrooms are small enough, builders will cheap out slightly, and instead of putting a floor trap in the bathroom, they'll just have a floor trap to the shower area and then grade the whole bathroom to that shower area. So we've got a 1 in 80 slope for the main area, and then it hits the shower, and then a 1 in 60 slope to that, and have your drain in the shower area. What you have to do when you start getting larger bathrooms is that you have to have a floor trap, and then also a shower trap as well, because when you're dealing with a 1 in 80 slope to your main bathroom that transitions to a 1 in 60 slope, you end up going through a lot of height. So for every 80 millimeters of travel in your bathroom floor, you're dropping down 1 millimeter. So for every 800 millimeters in your bathroom, you drop down 10 millimeters already. We want to limit our set downs in our concrete slabs to 50 millimeters. If we go beyond that set down of 50 millimeters, then we're having to starting to do drastic things with our slabs to achieve those set downs. So we want to minimize that. Also, when it comes to your drainage flange, as I mentioned before, there are 2 ways of doing it. One is with a dry screed and one is with a wet screed. So the wet screed option is by and large the popular option within South Australia, and this detail shows the detail that goes underneath the screed. So with our, if this detail was complete, we'd have a 20mm screed above this, where my cursor is just following that along there. So we'd have our screed above that, and then tiles above that. So this drainage flange here, this drainage flange there, is actually set down into our concrete floor. So that will, so at the point of pour, that drainage flange, actually you'll produce slight accommodation in the top of your concrete there, and space for that drainage flange to go in there. But that's the top of our concrete, and then we have our screed above that. So this top here, that's set down 50mm from our finished floor level for the rest of the building. So also, whenever you use a drainage flange like this, also known as a puddle flange, is that you need to have minimum 20mm of screed thickness here at that point. If we have 20mm of screed thickness there at that point, that only gives us an additional 30mm of room to move with our 1 in 80 slope to our, if that's to our general floor area. Can anybody do the quick maths to work out how many millimeters of distance we can have before we have our floor trap when we've got a 1 in 80, if we've only got 30mm to play with?
2.4 meters.
Yeah. Cool. Yeah, I didn't expect. Yeah, not many people are having to do maths in their head anymore. That's great. Yeah, so we've got 2.4 meters maximum. Now that's not a huge amount of space, and that's without imposing a 1 in 60 slope to our shower area, which is probably going to be about 1500mm or so. So you can only use that option where you've got a puddle flange in your shower for a fairly small bathroom. So probably what you're going to have to do for your disabled bathroom in your project 2 is provide a flange for your shower area, and then also another flange for your main bathroom area as well. But I'll let you go through those calculations to work that out. Also, whenever you have with your wet areas where you don't have a floor trap, if you decide not to have a floor trap in your wet areas, there is another way of getting around it, and that is to have all of your facilities in those wet areas to have overflow protection. So let's say we were building a house elevated timber floor, and we didn't want to produce a set down in that elevated floor. We really wanted to cheap out, and we wanted to keep that framing really simple. Another way we can do that, so we don't have a set down for our wet area sloping to a floor trap, is to have overflow protection on all of our things like laundry tub, hand basin, and bath. And then we can just get away with having a preformed shower base which is stuck onto our floor, enclosed by a shower screen. That's one way of getting around it. Has anybody ever noticed that on basins, hand basins or so, a little area at the back that if the basin fills up, it starts spilling out the back of that? So that's what that is for. So that's those that overflow protection is an option you can use if you don't want to be putting a floor trap in a wet area. But for our details with project 2, we'll be going with appliances that don't have that overflow protection and just our standard floor traps. So I'll quickly grab an image of a cross section of a puddle flange. Yeah, that's a fairly good one for illustrative purposes. So each of your manufacturers are going to have slightly different details when it comes to their puddle flange, and also for various different installations. So by all means, look, I guess I'll be overseeing these drawings anyhow, and I'll see your details come through, and I'll offer possibly some insights there. But just please be aware that there are many different details and many different applications, and it's good to choose a detail that relates to our application. One difference here for this one is that this one's on what appears to be a chipboard base, but for our illustration, this works fine. So we have our flange that's set into our floor like that, and you saw the one in AS3740 where the top of that flange sits flush with that finished floor level. So just quickly see that again. So the top of the flange sits flush with the finished floor level, and you don't have your waterproofing membrane kicking up. That is the best detail in terms of that height. But looking back at this one, so we've got a bit of a step up there. That's not fantastic. But then we've got our waterproofing membrane that carries down into that. Some drainage flange details will say that your waterproofing membrane has to carry down inside there. That's by and large the most common. But your puddle flange is made up of several components. One is that flange that goes down in there, and the next is the insert that goes into it. What it's ensuring is that water that comes down here into this floor trap or shower trap goes straight down there and then into our drain. So all that water is flowing down like that, but it enables that any water that seeps its way through this grout and into that screed can make its way along through the screed and drip down inside that. So over days and weeks, it can weep out of there. So several ways of doing it. This one, it enables it to weep down through these side sections here, but other puddle flanges have holes in the side that enable the weeping through. But the main thing about your puddle flanges is they come in two parts. So one lower section that's recessed into your concrete slab, an upper section that it's in contact with your tile bed screed. Have a quick flick through, see if there are other good details. So nothing that comes quickly. So that's fine. We'll leave it at that. So for our wet areas, we're going to have to do we've got our layouts from Revit, so that's fantastic. If we're going to be modifying those significantly, then we refer back to the clearance spaces in AS 1428.1, and then we do all of our waterproofing details as per an unenclosed shower. That means our water stop being a minimum of 1500 millimeters distance from our shower rows, and waterproofing of that entire floor up to that water stop. One final thing to mention is that your water stop, as shown in here, you've got things like that to show 1500 millimeter radius. One thing about your water stop is you don't lay them in a circular or semicircular fashion. They are rigid angles, and also you're not going to cut a semicircular cut in the top of your tiles. So basically your water stop is going to be here outside that 1500. It's going to go straight, then it's going to go straight again. That's what you're going to do. Beyond that, take note of all the things that are mentioned in these example diagrams, that you have to waterproof to your shower connection, and then also to all of your penetrations as well. and then waterproofing your junctions. So those waterproofing at penetrations, that can happen via either the painting of waterproof membrane in around your tap body and then siliconing in there, or there are actually proprietary waterproofing, these little seals that can be pushed in there. So if you cut the holes neatly with a hole saw, when you do your penetrations, you can push these rubbery cups in there that produce that waterproofing. I guess, yeah, because you're not installing it, all you need to say is that you have to waterproof to all penetrations there. But that can be done in several different ways. The main important point for installers is that you can still undo your taps to replace washers, etc., without disturbing that waterproofing membrane.
Excuse me, can you just make a note on the drawing that because we have to annotate so much, use the arrow, maybe just make a note. Is that all right?
In terms of what?
In terms for waterproof junction.
Yes, yeah. So for
yeah.
the sheet for these, no,
Not waterproof, just waterproof to show.
Oh yeah. So
yes.
yes. So just say yes. Just a leader saying waterproof to all penetrations.
Yeah, that's maybe
yeah.
Yes. Easier.
Yeah. Exactly. Yeah. So So I don't expect you to draw any of those proprietary fittings to do waterproofing or anything like that. No, I'm not expecting that at all. So just a note to say waterproofing of all penetrations. But what I do expect you to do is draw in the areas that have to be waterproof and the areas that have to be water resistant. So show that. So when you do cut your section through, show it just like it's shown in here, where you've got your darker sections for waterproof and your lighter sections for water resistant. Just so that I can see that you've worked through those. But you will, in professional practice, you will have to put together a whole series of waterproofing details that get attached to each project as well. So that's your disabled bathrooms and bathrooms. Next section we're going to have to look at, and this is probably going to be a fair bit of revision for everybody. It's to do with fire separation of buildings. So what I've heard, from what I've picked up from everybody, that you understand fire resistant levels quite well. So we'll keep this to an absolute minimum, unless you have any specific questions, etc. So we have to ensure that we don't have fire spread from neighbouring buildings into our buildings, or also from our sole occupancy units into other units. So we have to go to part C1, fire resistance and stability. Well, actually, before we do that, one thing you have to do with just about any project before you go launching into anything with the NCC is do your building classification. I think nobody needs instruction on working through building classification for this building. So we know what our building classification is. So then we go part C1, fire resistance and stability. So knowing our building classification and our rise in stories, so we've got 2 stories, and we've got to be a class 2 building. That's fairly simple. We're going to have type B construction, unless and there were some options put forward in terms of enclosed stairwells, etc., and fire sprinklers that enable us to be of a type C construction. But by and large, because your fire resistance levels aren't too stringent for your type B, that's what I'm expecting people to go down. That's the path I'm expecting people to go down, is accept type B construction. So what does that mean for us? Well, we know that it's type B construction, but for each building element must comply with specifications C1.1 as applicable. So we go then to specification C1.1 for our fire resisting construction. And we go down to type C. Accidentally just put that type B. Must have actually flicked right past it. So we head down to our type B fire resisting construction. So we have various different aspects spelt out there for various different elements, but in the main we're going to get all of our information from this, the FRL of building elements. So you're going to have to put notes as to the fire resistance level of each of those building elements. So for any load-bearing walls, and this is distance from a fire source feature. So can anybody think of what name some fire source features?
Fireplace.
Okay, yeah, well, yeah, fireplace, fire source feature.
Stove.
Stove.
Gas stove.
Yeah, yeah. Well, I guess yeah. Essentially, yes. These things are they're fire source features, and yeah, and so your air conditioning systems and so on, and any of these electrical things. But also your other fire source features are things a little bit more obscure, like property boundaries. You think like, okay, what sort of fire is a property boundary? It's a line, it's a cadastral line on a map. But because we can't control what's built on neighbouring allotments, we don't know whether there's going to be something right on that boundary and whether there's going to be a fire in whatever is built right on that boundary. We have no control over that. So a boundary is classed as a fire source feature. Or car parking is counted as a fire source feature. So we have to think about that. So for any load-bearing parts within 1.5 meters of a fire source feature, so within 1.5 meters of a boundary, for our class 2, 3 or 4, it's got to be 90, 90, 90 construction. Another important fire source feature are not only boundaries, but neighbouring units as well. Because we don't know whether somebody's going to be, cooking some stuff in a deep fryer and then go take a phone call or whatever and leave that stuff on the stove and then start a fire in their unit. We have no control over that. The only thing that we can control is to try to stop that fire spreading between separate units. So those individual units are also seen as fire source features. So because we've got a 110 thick wall or thereabouts separating our units, we're definitely within 1.5 meters. So we've got to have our separating walls at 90, 90, 90 as well. What's that? Oh yes, but ours are not. Yeah.
The other walls are, but the partition walls are not.
Yeah. So for any non-load bearing parts, it doesn't have to have the structural integrity component of it, so it's dash 90, 90. So, but it has to resist the passage of fire for that 90 minutes. So we've got our structural adequacy, integrity, and insulation. That integrity, that doesn't just relate to the passage of flame, it also relates to the passage of any noxious gases as well. So for 90 minutes, you can't have any smoke spread from one unit to another. But that's an important point in terms of the installation of any fireproof walls, is that they all have to be thoroughly sealed with fireproof mastics to achieve that. But yes, because we don't have to meet that structural integrity, it's going to be dash 90-90 for our separating walls. But for our floors that separate us from a car park, for example, that is going to have to be structural. There is a structural component to that, and also for any of our walls on the boundary of our building as well. They're going because I think everybody understands that we're set back not very far from the rear boundary. Everybody's noticed that. We're going to have 90-90-90 construction to that rear wall, and then for some of our side walls where we're getting greater distances, we can reduce that to some extent. So we're going to have fire separation between our walls, and then we'll go. But another part, so yes, you're definitely a bad neighbour if you set your neighbour's building alight, but other ways of being a bad neighbour is to be making lots of noise, and for that noise to be transmitted between units. And so because of that, we also have to ensure that those separating walls are not only fire resistant but also have limited sound transmission. Did you cover any of this in compliance? Yep. So you've had a look at the so I can know. So some people have met that sound transition, others haven't. So under health and amenity, we've got F5, so sound transmission and insulation. Fairly simple. I'll expand that. We've got, so under F5 we've got, and we're going to go the deemed to satisfy route, not the performance solutions for this. So we're going to have a look at F5.5, sound insulation rating of walls. So a wall in a class 2 or 3 building must have an RW plus CTR not less than 50 if it separates sole occupancy units. That RW, that's a resistance. That's a resistance weighting for how much sound can transmit through there. Now, I'm not expecting you to design systems at all that, or to work out ways of producing insulation that can have that resistance to sound transmission. All of that work has been done for you by people who supply walling products. So you've got, the CSR Red Book, for example, that sets out all of your fire separation walls, and you'll notice in columns in that they'll also show that sound transmission resistance as well. What I am expecting you to do though is to say that those walls have to have that sound insulation to meet at least an RW plus CTR of not less than 50 as per F5.5. Because we don't have any units above and below each other, that's basically the extent of what we're concerned with when it comes to sound transmission. For buildings where you do have the buildings below each other, you've got to worry about impact sound resistance as well. So stomping on timber floors, etc. How that travels through, plus also that the sound insulation between the two, and also sarking of pipes. Well, sorry, not sarking. What do you call it? Well, just wrapping of pipes to ensure that we don't hear people flushing their toilets from upstairs every day. So we don't want those sounds carried through the plumbing. But we're not going to have to deal with that with our buildings. We don't have any habitable buildings above or below. Another very quick thing to include in your drawings is you would have noticed that when looking at lifts, your lift manufacturers are saying this lift has been constructed in accordance with AS 1735.1 for disabled access. They're going to have all of those details there anyhow. The only important thing that we're going to have to think about with this for our drawings is right down the end at Appendix A, and that's this diagram here, because we're going to be showing our lift in elevation. So from the outside of our lift, probably we'll be showing that in elevation. If you are going to be doing that, then you're going to have to show your button heights. So we go straight to Appendix A from AS 1735.1 to see the heights of our direction indicators and our buttons as well. In terms of height of light beams, etc., not expected to put that in there and to show that. We won't be showing any of our drawings to those details. All we do is say the lift installation as per AS 1735.1, but we'll show our button heights, etc. for that installation. Other details, other minor details we're going to have to look at with our buildings are fall protection. So it's very important. Well, it's very stringent, and you probably would have covered this a little bit with stairs design. So you've got your rise and run dimensions with stairs, but then you also have to ensure that you don't have a 125mm sphere pass underneath your stairs for any open tread stairwells. That 125mm sphere just keeps popping up everywhere. So it pops up once again in relation to balustrades. So that 125mm sphere can't pass between balusters in the balustrades. And then we have heights of our balustrade for adjacent a stair, which is 865, transitioning to 1 metre high above a balcony or a walkway, etc. So anywhere where you can fall for more than a metre, you've got to have a metre high protection. So that's in section D, access and egress. We've got D 2.6 and D 2.24. Specification, sorry. Yeah, that's still a fair way off. Apologise. My apologies for the slow. So D 2.16, barriers to prevent falls. So a continuous barrier must be provided along the side of a roof to which general access is provided, and a stairway ramp and or floor corridor, hallway, balcony, deck, around mezzanine access bridge, or the like. I'm hoping you won't go putting air conditioning units on the top of your buildings simply just to make the passage through council easy, because council don't like to see services on top of buildings, but also in terms of making it easier for yourself in ensuring you don't need to have barriers to prevent falls, etc. on your roofs. It's also good not to include all your services up there. But if the trafficable surface is 1 metre or more above the surface beneath, you've got to meet these requirements. So for stairways, 865mm. So you're going to have to show that on your on dimensions. In front of fixed seating or a mezzanine or balcony with an auditorium, class 9B, we're not going to be that. So we're not. So our 700 millimeters doesn't apply. So in all other locations, 1 meter high barrier to prevent falls. So where required barrier is constructed of Y, it is deemed to meet the requirements of table D 2.16a. That relates to tension of horizontal wires to ensure that that 125 millimeter sphere can't pass through those wires. I'm not expecting you to be specifying any wire balustrades for your building. I think by and large it's going to be far simpler to have fixed railings. So you're going to have to ensure that those balustrades are at least at that metre height, and where not, change those. And then we go, and then the next important point is D 2.24, protection of openable windows. So you'll have some windows on your building which can be opened. So a window opening must be provided with protection if the floor below the window is 2 metres or more above the surface beneath, in a bedroom in a class 2 or 3 building, or class 4 part of a building, or class 9B, early childhood centre, where the lowest level of a window opening is less than 1.7 metres above the floor. A window opening covered by A must comply with the following. So the openable portion of window must be protected with a device capable of restricting the window opening. You probably don't really want to do that because you want to have, ventilation, etc., or a screen with secure fittings. And that I think is probably going to be one of the simplest retrofit things as well, is to produce a screen on the outside of your windows. So device or screen required must not permit our 125 millimeter sphere to pass through the window opening or screen and resist an outward horizontal action of 250 newtons against the window, restrained by a device or screen protecting the opening, and have a child resistant release mechanism if the screen or device is able to be removed, unlocked, or overridden. But put simply, if we've got any window openings less than 1.7 metres above the floor level, then we have to have fall protection through that if we're more than 2 metres above the ground. So that's our fall protection you're going to have to look at and go through. The last section that we're going to have a look at today is light and ventilation. So under health and amenity, so F5 was our sound transmission. F4 is for light and ventilation. So for our class 2 buildings and class 4 parts of the building, we have to provide natural light to all habitable rooms. We can look up that definition of, well, let's look up that definition of habitable rooms. We're at page 324. So habitable room means a room used for normal domestic activities and includes a bedroom, living room, lounge room, music room, television room, kitchen, dining room, sewing room, study, playroom, family room, home theatre and sunroom, but excludes a bathroom, laundry, toilet, pantry, walk-in robe, corridor, hallway, lobby, photographic darkroom, etc. So obviously going to exclude photographic darkrooms for natural light. So if we think about our units, we've got our bathrooms at the back. We don't have to provide that, the same light and ventilation to those bathrooms. Certainly, a well-ventilated bathroom is an important thing. So you either have fairly large openable windows for that ventilation, or you have exhaust fans to reduce condensation in bathrooms. But we don't actually have to meet those requirements for our light and ventilation of those. but for our main living areas, we do have to ensure that we meet those light and ventilation requirements. Should be very simple with our buildings. But just quickly, methods and extent of natural light. So, required natural light must be provided by windows excluding roof lights that have an aggregate light transmitting area measured exclusive of framing members, glazing bars or other obstructions of not less than 10% of the floor area of the room. So we calculate our floor area of the room, multiply by 0.1, that's the minimum size of the windows that we need. And our open the sky face court unspace open the sky open the veranda. If we're unable to achieve that, so we have that stipulation, or at the end of that sentence we have or. And or enables us to move on to this, so roof lights that have an aggregate light transmitting area measured exclusively for framing members, glazing bars, blah blah blah, 3% of the floor area of the room and are openable to sky, etc. So if you didn't have any windows there, yes, you can have a roof light. Where that does, where you do run into trouble there or difficulty with that is meeting the energy requirements of a building, because roof lights, transmit a great deal of heat into buildings, so it can be difficult getting your energy rating assessment to meet your 6 stars with that. So that's for our natural light, and then going down to ventilation. So natural ventilation, F4.6. Natural ventilation provided in accordance with 4.5a must consist of openings, windows, doors, or other devices that can be opened with a ventilating area not less than 5% of the floor area of the room required to be ventilated. So really simple way of remembering that is you just have to remember the 10%. So remember our 10%, and then half that window has to be openable to provide ventilation. That's the really simple way of remembering that. Also, another thing, and it's not applicable to our project 2, in fact it's not applicable to any of the projects that we have here, but it might be applicable to you in the future, is you can borrow light and ventilation from other rooms. So if you were to have, let's say you're doing an addition on an old bungalow, and that addition requires, basically putting a room in front of a window which initially was the only light source for that room. The way you can go about that is producing double the size of windows on your addition to enable the penetration of light into that rear room. So if we go back up here to 4.3, so natural light borrowed from an adjoining room. So glazed panels or openings have an aggregate light transmitting area of not less than 10% of the floor area of the room to which it provides light, and the adjoining room has windows excluding roof lights that have an aggregate light transmitting area of not less than 10% of the combined floor areas for both rooms and are openable to sky, etc. So what that means is that you have to have that window that is 10% of the combined floor area of those 2 rooms, and then in the second room at the back, that has to be that normal 10% of the floor area. And then for our ventilation, basically it's exactly the same at half. So the same once again. So there's that option for you if you're doing some additions on buildings. Yeah, apart from that, the only thing we'll have to do is I'll have to bring up AS 1421, 1428.4.1 for those tactile surface ground indicators. So that'll take me a little while to go through the library to grab that one. So we'll stop at this point. Any questions, etc., or so? Does everybody think that's covered all the nitty-gritty bits of the project? fairly well for moving on with those.